Hello, everyone. We're at the bottom of the hour. I see some people still trickling in. We've got a pretty large group that's attending us today for the paperless machine integration journey kind of discussion. It's nice to see a lot of interest for this one, which kind of aligns with my experience out in the field in the last probably 5 to 8 years, where more and more people are talking about the need and want to integrate their machines to other systems. I'll give it maybe another minute here or a couple, or maybe a half a minute before I start to actually kick off the actual webinar. Okay, well, we've waited about a minute and a half past the bottom of the hour, so I'm just going to get going. And obviously, those that did not attend can still get the recording for this webinar. Like I said, this webinar today is hosted by Paperless, MV2, and it's going to be talking about machine integration and yeah, kind of the journey as well as some examples. And like I said, kind of briefly when I was kind of killing time before I started the webinar, this aligns with a lot of the feedback we are getting, myself personally, as well as others from our company, are getting from our customers and just the manufacturing base itself, where they are needing and wanting to integrate to their machines for some pieces of data. I mean, we're obviously always trying to continually improve as manufacturers, be more productive, be more efficient, get better for on-time delivery, reducing scrap, all of those things, and machine information and machine connectivity will allow us to, get not only get the data, but also make the choices that we need to make in order to, improve our efficiencies and productivity. The machine integration journey, or I'm not going to go and belabor through all of the, different phases of industry, right? Everybody's heard the term probably out there, Industry 4.0. It's been out there for a while, but kind of just explaining the differences between, Industry 3.0 and 4.0. 3.0, we did have automation and computers and everything out on the shop floor, and that was mainly kind of individualized, if you will, where it ran a specific machine. Think of a very simplistic CNC machine where you had a program that was being downloaded to it to actually manufacture some parts. Obviously, over the years, we've expanded that not just to be a CNC machine, but it could be a mass production machine where it did multiple steps at the same time, and fed other areas. Or maybe you have robots that are actually feeding material into a machine that is automated, and then robots on the other end where they're actually taking parts off of that machine. I think another reason that maybe this is being highlighted is obviously to improve efficiency, but another one that I'm seeing a lot of is our workforce. The issues of trying to find individuals and keep individuals is becoming more and more difficult. So now we're kind of being forced to say, all right, and I say we, I'm talking about manufacturers, of course. We're being forced to kind of say, all right, what else can we do? We still have this production need. We still have a demand from our customers to make and manufacture things, but we don't have the manpower. So let's augment or substitute that manpower with robots or machines that can automate that process. So it's kind of two different things for kind of driving this demand. What is it? What is MI? What is machine integration? Well, really what it is, it's connecting people, data, devices, and systems all together into one. It's making everyone more connected so they can actually be more intelligent as manufacturers, as supervisors, as certain even individuals on the floor. When you're more intelligent, you can become more efficient and more productive, right? It's also enabling these machines to communicate to your MES system, your ERP system, other SCADA devices as well. And then even, talking about this term out there, I've heard machine greening or retrofitting. where you're basically going to modify an existing piece of equipment, maybe it's an old machine, and get it ready for the connectivity or the IIoT, the Industrial Internet of Things, where you can actually say this machine can now connect to something else to publish data that's going around. But I don't want to leave it at just saying that you have to do something to your machine itself in order for it to be retrofitted or to do this machine greening, as I mentioned. We also have customers that we work with that just are adding a sensor during the production process. Maybe they have an old press brake machine, right? That is not, capable of communicating, or maybe an old stamping machine or something like that. Well, we can have sensors out there that can actually, be attached to that machine to capture different pieces of information. Obviously, it's not going to be as robust as you have with your full embedded kind of PLC controller in a CNC machine where it can capture any number of data elements. But maybe you're just looking at some specific elements that you would like to capture. What are the benefits? Well, just to briefly say it, there's obviously a lot of benefits for connecting to your machines through a machine integration kind of effort. I already mentioned about improving efficiencies. Obviously, processes can be improved as well, and performance. If you think about kind of like a real world example here, if you are running a machine and you're expecting, just say 60 pieces per hour, so a piece per minute, right? If you're getting feedback from that machine real time, immediately every cycle it goes through, you'll be able to know right away at the second it's doing a cycle, whether it's ahead of schedule or it's behind schedule. When you think about that, as far as improving your performance and your efficiencies, obviously you can tell if you're behind, make the necessary adjustments, and actually, get back on target, right? And then if you think about it as a bigger picture, right, from your processes standpoint, it's like, your planning processes is based off a number of different things, right? What is currently being worked on today? What's the current status of it today, right now? What's the rate at which I can run it? Are those standards accurate? All that information can be now captured from this machine integration to get better data. When I say data, I'm not only talking about your data for what you're currently working on and what you're currently producing, but also how you're producing it. Maybe you want to validate that the run rates you've defined in your ERP system are still accurate, because maybe you've actually improved some of your processes and now you want to adjust your run rates to mimic what is actually happening on the floor, and then think about what that does from your planning perspective. That obviously improves your accuracy of your planning as well. It can obviously help, identify failures or even predict potential failure points. It can eliminate those bad habits or those bottleneck areas, or other things that would potentially provide losses out there on the floor. Real world example of just thinking about identifying failures. There's a lot of different machine types of integration that can identify if that machine is running or it's not running. Obviously, from a CNC machine, we can obviously get a signal from a CNC machine to tell us that. But also there's other devices that can say, I know that there's actually amperage or voltage that is actually being sent or being run through this machine, and that maybe determines whether that is running or not running. Or maybe there's an external sensor that is counting the quantity of parts that are being produced, and maybe after a certain time period and I don't receive any parts, then it will signal some type of downtime event that could potentially happen. I think we're all kind of hearing about the AI and artificial intelligence, right? Well, that data that is being captured, whether it's from a human or whether it's from a machine, is necessary for AI to do its job, which is to say, I can now make the decisions for you because of all the information that we've captured and the rules that were defined, et cetera. So it's making those decisions automatically for you. But in order to get there, you still need to have that data, which means you need to have some type of integration to your machine or your people. I mean, it doesn't matter if it's a human or a machine, getting that data into the system. I want to kind of release a poll question or tool here, and that is this one here, which is saying, do you guys have machines today that have the capability to capture data. And if it's a yes, obviously that's 100%, but you may have some machines that do and some machines that don't. I'll let that run for maybe another couple of seconds here. Let's get most of the audience. Um, Most of you are saying some. I would say 60 to 70% of the audience says some, which means you've got a mixture that some can and some cannot. And then I'm gonna release another poll question here. Oops, here we go. And that there's actually two questions in one. It's just, whether or not you want to capture information from your machine, and then also, do you currently capture information from a machine or a sensor? And we'll get onto details later on as far as like, where are you capturing it and what is it doing, right? So from those that responded, it's 100% that you do capture some data from your machine, or that you want to capture data, but then it's probably 55-45 split between that you capture today or you don't capture today, just to give you guys an idea of the audience that we're dealing with today. Okay, so I pulled a quote out there that I found, which was, how important this machine integration thing is that, from a value standpoint, meaning that how much you can actually get payback for improving your current operations is like 633 billion to 1.8 trillion. And obviously that's across all manufacturers, and some may have more and some may have less. But even if you just had a 1% or a 5% improvement, what does that do for your bottom line? Obviously, it's pretty large. What are its uses, right? We can do asset tracking as far as I just mentioned, like machine monitoring. You can help with process monitoring. Are my pieces being reported as expected? Are the rates that our machines are running and producing the item that it's expected to produce? Is it accurate? Is it on schedule? Predictive type of maintenance, quality control. And if I have scrapping parts and things like that, obviously machines can understand if something is bad and start the process to say, what should we do with it? What are some of the challenges? Complexity, cost, change management, right? I hear these three things all the time. Complexity and cost are probably the two big ones. Change management is like, willingness to change, right? But complexity is saying, gosh, how do I get from point A to point B? And I've got some really good customer examples kind of built into my presentation today that I'll get to. Just that, and it really is focusing on starting small. What are you guys trying to capture? And let's keep this simple so that we're not trying to design, the never-ending gobstopper, or the car that never needs maintenance or never needs gas or never needs electricity, right? And then obviously that's going to reduce your cost too. You can start with very small areas and a small data set and a small objective and kind of build out from there. Getting started, and this is where a lot of people that I've talked to, a lot of research I've done as well, people say, what, the first step is to automate your machine and make sure that they connect to either the network or to some system, right? Whether it's your ERP system or your MES system, or maybe even a third-party, machine metrics kind of system. And really what I do is I'm telling our customers, and this is where I've seen success, is our first step is really to analyze what do you need and want to track. If you are having a problem with scrap, then let's just focus on scrap. Let's not focus on the temperature of the machine or, the output of the machine or things that I just want to know how many scrap pieces are being reported and where they're being reported for what items, et cetera, and what machines maybe it's and who's running it at that time. There's a lot of things you can dive into just for that scrap scenario that I'm mentioning to figure out, all right, what can we do to improve it? So let's let's figure out what we want to do first, and then we figure out what data is needed to support what you want to kind of correct or track. And then we can actually say, all right, let's see if the machine has the capability to capture the information that we want it to. And if it doesn't, then we kind of roll out to say, where does this go to next, right? What's the next step to get the information we want, or we need to actually get the metric that we want. It's kind of like just walk through here a little bit saying, where does it fit, right? Where does this machine integration fit? Everybody's probably seen this little pyramid out there, which is, your IIoT, MES, ERP, and business intelligence, right? And that's just that pyramid of everything kind of goes upwards, right? Well, that machine integration kind of falls in between a lot of different things between MES and IIoT. So you think about your execution network out there, right? Where you've got your work in process production kind of stuff, your inventory stuff, you've got your SCADA and PLC and your machines, you got your human processing, you've got your quality and inspection, and that could again be machine related as well. And then up on top, you've got your ERP system, right? Well, this is where that MV2 and inside of MV2, part of MV2 is this machine integration piece. So not only do we have our standard manufacturing execution system, but we have also built it out now that says, all right, we can, not only grab information from machines or sensors, but we also can send information to machines and sensor. To kind of drill down a little deeper how this kind of works, I'm saying that if I've got a machine or a sensor or some piece of equipment that can capture some information on the very left-hand side, right? That's going to, capture my data, right? And that capturing of the data could be just into the device itself, meaning I have a tag out there that's being representing of a temperature or quantity or a count or something like that. Or that could go into some third-party type of application. I mean, like a Hexagon or Factory Wiz or Kepware or Machine Metrics or we can even go direct. There's other ones out there. I just kind of chose the ones I've kind of run across in my efforts here. And that capturing the data says, all right, if that machine sensor is capturing data and put it into a Factory Wiz type of application, right? And Factory Wiz maybe doesn't have the knowledge or how to communicate the transactions to your ERP system. You know what? We can grab it from Factory Wiz and take it somewhere else, or we could go directly to that machine as well. So there's a lot of different things that can be done in this middle layer here. And this is where we get into the paperless layer, right? Where we've got this paperless MI that's going to say, all right, I'm going to take the data captured. And if we say capture, we can also go capture it ourselves, right? If the machine has the capability, or if that sensor does, or if you want us to, use some other tools, we can capture that data. And then once we capture it, now we can actually broadcast that to MES, and now you get all the benefits of the MES solution for production, inventory, quality, and Kanban types of transactions, and then also the dashboards that can be seen and broadcasted out there on the floor, or any of the other analytics or the alert messages that can be sent out. And then ultimately, now that MES system can send it off to your ERP application, whether that's Infor or Microsoft D365 F&O or Business Central or SAP or Oracle. It doesn't matter. But this is that kind of that flow here of saying that this machine integration piece kind of lands in between MES and ERP is kind of the conduit of the information, and it can also go all the way down to the machine if you wanted to, or it could utilize one of these third-party products to capture that information as well. And remember, we can also send information down. Not only can we receive information. Actually, I'm going to back up here. It's a good time to have another poll question out there. And that is this one here, which is, for the data that you guys are capturing, for those that are capturing machine data today, are you guys sending that to MES and ultimately to your ERP system? So far, the majority is no. So there's probably like 15%, or now it's 25, 75, or 75% of the, excuse me, 75% of the people that responded here do not send that information on. And that's it for my poll questions. So now I'm going to get into a couple of customer examples. And I failed to mention in the beginning, if you guys have any questions, feel free to type them in, and I'll look at the question and answers, and I'll try to answer them at the end of this session the best I can. So back to our PowerPoint here, this is really just probably the most simplistic type of machine integration you could do. And you watch this little video of one of our customers, and what it's doing is actually scanning those boxes that are flying on this conveyor belt down the line. And these are coming right off the production line. They're being boxed, and you can see that scanner. It's a fixed scanner out there that actually is reading that barcoded label that of the box that is passing by it. I actually slowed it down so you could actually see it happening, and what it's doing. There's a scanner, scans that label, and then what it's doing, it's actually performing a transaction to receive material into stock, not only in the MES system, but also sending that information ultimately to your ERP system. So again, you're eliminating that person having to, report pieces on a terminal, or worse, actually report pieces on a piece of paper. They actually have their scanner set up. Say, all right, my inventory is increasing on hand, which obviously, if you're doing backflushing for the material used, that could be happening at the same time as well. So that's like the most simple thing, where again, we think about machine integration. Sometimes we think about the very complex machine type of integration versus maybe the simplistic. This is a very simplistic implementation where we, put a scanner on the line and started to record pieces to stock for finished goods. All right. My next example here, and this is a good example of another kind of old, outdated machine that doesn't have the capability to collect information, and if it did collect it, it has no way to actually connect to another system. I mean, there's no RS-232 ports, there's no network capability, etc. So what we did is just, all right, let's put a sensor on the input as well as the output, which means this machine is actually having paper being put into it, and then on the back end, there's envelopes that are coming out of this machine. So that the blurry picture there, you can tell how fast the pieces of paper fly through this machine. And because we have those two sensors, one at the input and the output, we can obviously do the math to calculate how many good pieces were produced, as well as how many scrap pieces were produced. And then also figure out the rate at which this job is running. So we can tell right away whether or not the job is running at, 60 pieces per hour or 5,000 pieces per hour, and compare that to the expected rate to actually give some additional feedback to the operator, as well as the supervisors, managers, etc. Now, here's just an example of that machine actually running with the external sensor. You see my cord there. It's actually connected to an Ethernet cord goes out to a PLC after that. And then what we did is we actually kind of built them a little dashboard here that says, this is the machine, how it's running, kind of comparing it to its expected run rate, etc. And then we actually even took this further and created a custom or dashboard for these guys. And it's a big 55-inch monitor out on the wall that says, all right, you know what, these are the 7 machines I'm currently looking at. Each machine is a row. And I can see right away that I've got, 3 machines that are currently running. 2 are running okay because they're green. 1's running a little bit slow. It's running at 68% of performance. I can see other details as well. And then the other 3 that are red, those are all in setup mode, which means that they're currently being set up for the next job. And the last row there that's all red, that's an automated downtime event from that machine. If you remember me earlier stating, you could put a sensor out there and says, all right, for this customer, they said if there's a time interval of 8 minutes or longer where we have not recorded a piece complete, we're going to take this machine down and put it into a downtime state, not only broadcast it on this dashboard out there on the floor, but we're also going to send alert messages out to like the maintenance department to say, hey, this machine has been down for so long, someone needs to go take some action. And then there's also some kind of management level dashboards that were built as well with different KPIs and sorting and filtering and more of going over historical data. My last example is kind of taking it more to that complex state, right? So this complex state, this is a line for one of our customers where it's an aluminum, not extruding, but they extrude aluminum, and then they actually take pieces of aluminum, actually manufacture them into parts, right? And they've actually automated this line where they've got a robot at the beginning where it's loading up that conveyor. It's taking parts off that conveyor belt, loading them into a CNC machine, and then it's offloading them, and another robot actually puts them into a box to package them. So this is their line. And you can see here the parts on there that get loaded. Obviously, there's a screen here that says the exact job that is running, and more importantly, how that job is running, whether it's running on schedule or not on schedule. You can see everything currently right now on that board is green, which is great. Here's a closer look at the jobs that are currently running, the rate, the expected quantity, all that standard stuff from our MV2 application. But now, if you look at the next screen, this is a screen that now it's got a little red border on it. And that indicates that machine is currently in a downtime state. And that downtime state was triggered from that machine itself. There's a CNC machine that was running. It noticed it was down. It actually, populated an event that we actually have a service to go look at. And that service says, all right, I know that you are now down. We're going to take you down in MES. We're going to send out alert messages, like I said before. And I think I also mentioned that it goes onto a board over there. So here's an example of that board where that machine is currently red, it's down. Another machine is running, and the other 4 machines are currently idle. They're not being worked on. And the other thing, again, more complex situation, is we actually are communicating to this machine to allow them to be able to run it or not run it. And what this customer did is they put a box over your standard kind of start button, right? And they are not allowed to start this machine until that downtime scenario has been corrected. And they wanted to do this because they are very keen right now on understanding why the machine went down. And they know it's down, which is good, but they want to know why it's down so they can improve their continuous efforts to reduce downtime. And a good example for this customer is, they had a scenario where they're a 3-shift every single day of the week, right? So they had no ability to add additional shifts, and they were being told by the operator and the supervisor and even the plant manager said, you know what, this machine is at full capacity. We cannot run any more parts through it. It's tapped out. Well, they started to investigate downtime, and what they were currently running is they were running about 9 million pounds of aluminum through that machine every year. So they started to investigate, all right, how long does this go down? How long does it take to rectify that downtime scenario, et cetera, et cetera. They were able to take this machine from producing 9 million pounds of parts a year to 16 million pounds of parts a year, just by focusing in on reducing the amount of downtime or increasing the availability and utilization of this machine. So that's how important it is to understand, that machine integration will tell you when it's down. You can react to it so that you can keep it up and running as much as possible. With that, that's the end of my session, which is right at the top of the hour. I will open it up to any questions, and then kind of just tell you what's coming down the pipe for us. We have another MV2 session coming out on April 17th, really focused on getting things right? Meaning like the right machine, the right material, the right insight. I wanted to put right manpower out there as well, but that's a whole another topic for another day. I'll give it another second or two here for anybody to ask any questions. I don't see any out there. And if there are no questions, now I appreciate everybody's time. Like I said, this session was recorded. Please feel free to go and review it at your leisure. And we hope to see you on April 17th for our next paperless webinar. Thanks and have a great day.